Voyager 1, which has been traveling through interstellar space for more than 45 years and is trailing a long grey beard by this time, not really, suddenly began to send strange signals to Earth. Even more bizarre, there are no signs that the probe has broken or anything. Scientists from NASA are desperately trying to find the reason. So, what exactly happened? First of all, let me tell you a bit more about Voyager 1 and its long journey. Voyager 1 is an American space probe that scientists from NASA sent into space on September 5, 1977. Voyager's goal was to explore the outer planets of our solar system, namely Jupiter and Saturn. Initially, scientists assumed that the mission would take about 5 years. The joke's on them, the probe exceeded all expectations. Not only did it fulfill its mission, but it's still working for much longer than expected. Voyager 1 has been wandering around space for more than 45 years. It's hard to estimate what Voyager 1 has done for science. Firstly, it successfully sent a lot of photos of Jupiter and Saturn to Earth. By the way, you can even check out these photos yourself, all of them are published on the NASA website. Thanks to Voyager, we also discovered several new moons of Jupiter and a previously unknown system of its rings. We learned that Jupiter's famous red spot is actually a giant, superfast storm. After leaving Neptune's orbit behind, Voyager also sent a lot of important data about interstellar plasma. So, Voyager 1 successfully proved to scientists how useful it was. After that, it happily headed for its next goals, the Kuiper Belt and the heliosphere. The Kuiper Belt is a ring of icy bodies that extends from Neptune to a distance of approximately $50 from the Sun. It's kind of similar to the asteroid belt, but about 20 times wider and 100 times heavier. The heliosphere is an area around the Sun where the pressure of the solar wind is balanced with the pressure of interstellar gas. Yeah, I know it sounds like some hard scientific stuff, but just keep in mind that this data really helps us understand the universe as a whole. So, this is Voyager's last task, to tell us more about interstellar space. The probe has already sent us more than 60 frames for a mosaic of the solar system from a distance of over 4 billion miles from Earth. Scientists used these frames to make a big colored picture. The photo was called the pale blue dot, and you've probably already guessed what that dot is. Yep, that's what our Earth looks like through Voyager's eyes. This photo clearly shows how tiny we really are and how precious and fragile our planet is. But Voyager 1 also has another, even more important mission, to tell other civilizations about us humans. You might have heard about the famous Voyager Golden Records. People created many audio and video files and added them to these records. There are a few sections. The first one contains hello in 55 languages, including ancient and extinct ones. Almost 80% of the recordings are different musical pieces, like Beethoven, Mozart, and Stravinsky, folk music from different countries and ages, and a bit of the blues, like famous songs by Louis Armstrong and Chuck Berry. The remaining 20% of the recordings contain different human voices, sounds of nature and animals, as well as 116 images encoded as audio signals. There are also recordings of speeches by Kurt Waldheim, a former UN Secretary-General, and Jimmy Carter, a former US President. These are just some friendly messages. In addition to the records, scientists also packed a needle for playing them. Don't worry, they also left a simple drawing that showed how to use all this stuff and how to translate the sounds into pictures. They added Earth's coordinates, which they created using a pulsar map that shows the position of the Sun in the Milky Way. The record was packed in an aluminum case and covered with gold to protect it against radiation and cosmic dust. Carrying this record, Voyager 1 set off on its long journey, and it has already traveled quite a distance. Right now, Voyager 1 is 154 astronomical units away from us, that's about 142 billion miles. This makes it the most remote human-made object. Initially, this title belonged to the Pioneer 10 mission, but Voyager overtook it in 1998. What a bargain for NASA! It's way beyond its best before date. Voyager 1 is actually so cool that it even overtook its twin brother, Voyager 2, which, by the way, had been sent into space 2 weeks earlier. Voyager 1 moves at a speed of 9.7 miles per second, that's 35,000 miles per hour. Even the fastest sports car in the world travels at a speed of only 305 miles per hour, so it's hard to imagine the speed of Voyager. Anyway, at the moment, Voyager is heading to the borders of the Oort cloud. That's the name of a hypothetical layer of icy objects surrounding the solar system. Astronomers haven't confirmed its existence yet, but they're almost sure it's there. After all, even black holes were only a theory not so long ago. Unfortunately, Voyager 1 won't return back to the solar system. It'll keep in touch with Earth at least until 2025, but eventually, we'll lose the connection with it for good. In 300 years, it'll reach the borders of the Oort cloud, and in 30,000 years, I won't be around then, it'll finally leave the solar system. If nothing happens to it along the way, in another 10,000 years, Voyager 1 will approach the red dwarf star Gliese for 45 in the Giraffe constellation. In the future, the probe will probably keep wandering around the Milky Way galaxy. Now, let's finally discuss the mysterious signals part. So, what happened? Well, a rather unusual thing. NASA's Jet Propulsion Laboratory, which monitors and controls both Voyagers, reported this problem in May 2022. Our veteran spacecraft suddenly began sending strange data to Earth. The whole situation puzzled even engineers from NASA. Now, I bet you're thinking, come on, the thing just probably broke down or something. But the truth is that Voyager 1 is totally fine. It works as usual, receives and carries out commands from Earth, and collects and sends scientific data. But the readings of the AACS, which stands for Attitude and Articulation Control Subsystem, don't show what is actually happening to Voyager anymore. This system supports the orientation of the probe in space and helps it keep in touch with Earth. So, basically, the signals mean that the probe's orientation in space is messed up, but scientists claim this is not the case. They know that the source of the antenna signal remains in the same position relative to Earth as planned. The problem hasn't triggered any of the onboard fault protection systems. The probe hasn't even entered safe mode. So, what in the world, or universe, is going on? Suzanne Dodd, the head of the project, says that the problem is not actually that unexpected. After all, Voyager 1 is already 45 years old. The expert admits that what's happening to the probe remains a mystery to them. They don't know exactly where the incorrect data is coming from, and it's unclear how this will affect the operation of Voyager. She adds, though, that it's not that surprising considering that the probe is in interstellar space. There's a very high level of radiation there. No spacecraft has ever reached that point before. Scientists from NASA say they'll keep closely monitoring the data coming from Voyager 1 until they figure out the problem. If they find it, the management team will try to fix it. Otherwise, the team will have to adapt to the new conditions. It might not be enough just to understand the problem, though. It takes as much as 20 hours and 33 minutes to receive the signal from Voyager, and it takes the same amount of time to respond to it. Well, at least the second spacecraft, Voyager 2, is totally fine, even though it's also currently in interstellar space at a distance of 12 billion miles from Earth. Anyway, we can only wait for news and hope that the problem will be resolved. I actually wonder, how much longer can Voyager 1 last? Will it be able to fly to the borders of the Oort cloud in 300 years? What do you think? I'd like to hear your thoughts in the comments. On August 20, 1977, the most ambitious space mission took off from Earth. The main goal of Voyager 2 was to study the outer solar system up close. It became possible because of a rare alignment of planets. Voyager 2 was supposed to study all the gas giants of the solar system: Jupiter, Saturn, Uranus, and Neptune. Astronomers also hoped that Voyager 2 would be able to find and explore the edge of the solar system. Since Voyager 2 was built for interstellar travel, the probe was equipped with a large 12-foot wide antenna, allowing the spacecraft to send data it gathered back to Earth. During its journey, the space probe discovered a 14th moon of Jupiter. Voyager 2 was the only spacecraft to study all four giant planets from up close and was the first human-made object to fly past Uranus, where it found 2 new rings and 10 new moons. Voyager 2 also flew by Neptune and noticed its great dark spot, a colossal spinning storm in the planet's southern hemisphere. This storm is the size of Earth and moves at a speed of 1,500 miles per hour, making these winds the strongest ever recorded on any planet of the solar system. In the history of space exploration, only 5 spacecraft have managed to leave the gravitational pull of the solar system: Pioneer 10 and 11, Voyager 1 and 2, and New Horizons. People launch thousands of objects into space, and these objects easily overcome Earth's gravity, but the Sun is around 300,000 times as massive as our home planet. That's why escaping its gravitational pull is far more challenging. Even more impressively, Voyager 2 is the second human-made object in history to reach the space between stars after passing through the heliosphere, a bubble of magnetic fields and particles produced by the Sun that protects the solar system. 2 years after its launch, Voyager 2 started transmitting the first images of Jupiter. The space probe provided scientists with much-needed information about Io and Europa, 2 of Jupiter's largest moons. Then, the space mission passed by the gas giant itself, with the spacecraft at a distance of around 400,000 miles from the planet. That's when the probe noticed some changes in the shape and color of the Great Red Spot, an enormous, long-lived storm system, similar to a hurricane on Earth, but much, much larger. 2 years later, Voyager 2 reached Saturn, discovering spokes and kinks in some of the planet's rings. While the spacecraft was flying behind and past the gas giant, it passed through the planet Saturn's rings. At that time, Voyager's speed was around 8 miles per second. For several minutes, the probe was hit by thousands of micron-sized grains of dust, which kept shifting its direction. As a result, its control jets had to fire many times to stabilize the vehicle. After Voyager 2 explored Uranus and Neptune, it headed out of the solar system. Its instruments were put in low-power mode to save energy. In August 2007, the spacecraft passed the termination shock, which is the boundary marking the outer limit of the Sun's influence. Here, the solar wind slows down. By the summer of 2013, the probe had reached interstellar space. When it comes to sending and receiving signals in space, there are 3 factors to consider: distance, power, and time. The farther away a spacecraft is, the farther a signal has to travel before it reaches it, and the longer it takes for this signal to catch up with the spacecraft. When it finally gets there, the signal is extremely weak. Another problem is that once the spacecraft is launched, it can't be upgraded. It's literally stuck with the technology it was outfitted with. Additionally, such spacecraft as Voyager 2 are powered by radioactive fuel. As the special material radioactively decays, it releases heat, which is converted into electricity. Unfortunately, as more of the material decays, the spacecraft has less power for receiving and transmitting radio signals. Despite this issue, we haven't lost contact with Voyager 1 and 2. That's because new and more powerful technologies have appeared on Earth, allowing signals to reach much farther than before. This is why it was possible to stay in touch with Voyager 2, which entered interstellar space in 2018 and has already traveled almost 12 billion miles away from Earth. But in March 2020, the main piece of equipment that allowed scientists to exchange signals with the spacecraft was switched off, and communication with the spacecraft stopped. NASA spent around 11 months upgrading its Deep Space Network, DSN, and installing new hardware. The DSN is an international array of huge radio antennas that help astronomers on Earth communicate with interplanetary missions. These antennas are located in California, Madrid, and Canberra. The one used to keep in touch with Voyager 2 is a 230-foot wide dish in Canberra. This is the only equipment that can send commands that reach the probe. This antenna, known as DSS-43, started operating in 1972, 5 years before Voyager 2 and 1 were launched. At that time, it was only 210 feet across. Since then, the dish has received many repairs and upgrades, but those 11 months were the longest time the antenna was offline. In October 2020, the antenna was finally ready for a trial after all the upgrades and repairs. The mission operator sent a set of commands to Voyager 2, and after many months of radio silence, the spacecraft returned the signal, confirming that it had received the call. After that, the spacecraft carried out the commands. While the dish was offline, mission operators could still receive scientific data and health updates from Voyager 2, and astronomers continued to receive data from interstellar space, the region outside the Sun's heliosphere. However, they couldn't send any commands to the probe since it had traveled too far away from Earth. The upgraded antenna received 2 new radio transmitters, and this was done just in time. One of the transmitters used to communicate with Voyager 2 hadn't been replaced in almost 50 years. The antenna also got new cooling and heating equipment and other electronics necessary to support the advanced transmitters. Now, a curious thing about the Deep Space Network is that its radio antennas are positioned in a very precise way. They are spaced equally around the globe, ensuring that almost any spacecraft can stay in touch with at least one facility at all times. But Voyager 2 is an exception. In 1989, it made a close flyby of Triton, Neptune's moon, which was the only close encounter people had with the 8th planet of the Solar System and its moon. By the way, Triton is the largest known object believed to have originated in the Kuiper Belt, a donut-shaped ring around the Sun full of icy objects. Voyager 2 discovered Neptune's ring system and its tiny moons. The probe also gathered a lot of amazing information about Triton. For example, it became clear that the moon is covered in cryovolcanoes. Instead of spewing molten rock, these volcanoes spit ice consisting of water, ammonia, and methane. When the New Horizons spacecraft flew past Pluto more than 25 years later, it discovered the same phenomenon on the dwarf planet. To make this detour, Voyager 2 had to travel over the gas giant's north pole, but this changed the probe's trajectory, deflecting it southward relative to the plane of the planets. Since then, Voyager 2 has been moving in that direction, and now the spacecraft is so far away that it's out of reach of the radio antennas in the northern hemisphere, specifically those in Madrid and California. This makes DSS-43, located in the southern hemisphere, the only dish powerful enough and broadcasting at just the right frequency to send commands to Voyager 2. Voyager 1, the probe's faster-traveling twin, didn't change its trajectory after passing by Saturn, taking a different path instead. As a result, it can now easily communicate with the 2 facilities in the northern hemisphere. The upgrade at the Canberra Deep Space Communication Complex has also benefited other space missions, including the Mars Perseverance rover, which landed on the Red Planet on February 18, 2021. The dish will also be crucial for exploring other planets and the Moon. We still can't find the source of the mysterious signal we've been receiving since 2018. We receive it every 22 minutes, and nothing can explain this. Some scientists even believe it could be coming from another civilization we haven't met yet. This strange radio signal wasn't found by a scientist on a serious mission, it was actually discovered by a college student doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals when he finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough, but despite checking different frequency data, they hit a dead end. However, Natasha then spotted a pattern: the signal repeated every 18 minutes. This was huge, but just as they were gearing up to study it further, the signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up, and they were ready to give up. Then, suddenly, a new signal popped up. This one kept blinking for 5 minutes, then it disappeared, and then it came back exactly 22 minutes later. The main question was whether this signal was related to the 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that yes, these signals aren't anything new. They've been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there, yet its source remains a mystery. The signals still pop up every 22 minutes on NASA's screens, always ending with a frustrating match not found message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So, maybe it's a way for extraterrestrial folk to communicate their location. While that idea may sound exciting, we need to be careful about jumping to conclusions. First, we don't have solid proof for that. Before any concrete evidence, it's just speculation. Also, there are other more plausible explanations. Most likely, it comes from a natural phenomenon, and there are a couple of theories for that. The first one is the pulsar theory. Imagine a huge star in space, much bigger than our Sun. Sometimes these big stars finish their life journeys in a spectacular event called a supernova. When this happens, the star's core collapses, becoming super compact, as if you're squeezing all the stuff from that star into a tiny space. That tiny, super dense core is called a neutron star. Some of these neutron stars are extra special, we call them pulsars. They get their name because they seem to pulse with energy, like a space lighthouse. These pulsars have incredibly strong magnetic fields, much stronger than what you'd find on Earth. They're like enormous magnets in space. Because of this, they shoot out beams of energy. They're also spinning super fast, so these beams of energy seem to pulse on and off as they spin around. Now, the strange signal we detected seems to have similarities with pulsars, but not quite. Pulsars usually have a predictable lifespan and slow down over time, eventually stopping their radio signals. In contrast, our mysterious signal is quite persistent and is blinking beyond what's expected for pulsars. So, maybe it's not a typical pulsar, or not a pulsar at all. There's also the magnetar theory. A magnetar is another type of neutron star. They're like supercharged versions of pulsars with even stronger magnetic fields and slightly longer pulsating periods. Maybe this is what causes our signal's intense persistence. However, when we plotted the data, we also realized the signal didn't match the magnetar vibes either. Magnetars not only send out radio waves but also powerful X-rays because they're so energetic. But the signal we received was only sending out radio waves. So, we figured it's not a pulsar and not a magnetar. The signal's behavior is very strange and suggests an unnatural source. This means there might be something in the universe that scientists haven't fully explored yet, and there is a space object that we don't know much about. The final theory is the so-called dwarf pulsar. Sounds a little dopey to me, couldn't help myself. Now, a dwarf pulsar is like a star that blinks with light flashes, similar to pulsars, but it takes longer for each blink. Usually, white dwarfs are the leftovers from smaller stars. They don't blink because their magnetic field isn't as strong as pulsars. But when a white dwarf becomes pretty hefty, almost the mass of our Sun, it gets super dense and starts pulsating with a strong magnetic field just like pulsars. They have a cool quirk: white dwarfs are made of electrons, not neutrons like pulsars. When these charged electrons start dancing with a magnetic field, they shoot out periodic light flashes, which happen every 100 to 1000 seconds. As you remember, our signal has a period of 22 minutes, 1320 seconds, a bit longer than the usual white dwarf pulsar, but it's much closer to the truth. So far, this sounds like the most plausible explanation, but even this theory isn't fully confirmed yet. This just shows how much there is in the universe that we're still figuring out. For example, fast radio bursts, another mysterious type of signal we've been detecting, are like quick, intense bursts of energy in the form of radio waves. They have a ton of energy. FRBs are so powerful that sometimes they can be brighter than entire galaxies. Now imagine this: they release as much energy in a few milliseconds as our Sun does in 3 whole days. Wow! These bursts happen all over the sky with huge frequencies, although some have been detected with lower frequencies. Every day, we catch around 10,000 random FRBs in the sky. Some of them repeat, but most happen once and disappear forever. Unfortunately, most of them only last for a fraction of a second, and by the time their energy reaches us, it's 1,000 times weaker than a mobile phone signal from the moon. This is why, despite their brightness, there's still a lot we don't understand about them. We're still trying to figure out what causes these FRBs. They could be coming from different sources, like already mentioned magnetars, colliding stars, or even merging galaxies or white dwarfs. As these bursts travel through space, they pick up information about the cosmic environments they pass through, like interstellar gas clouds. It's very unlikely that FRBs are some messages from extraterrestrial beings, though, not only because there are thousands of them every day all across the sky, but also because we know that the sources of these bursts must be incredibly energetic themselves. Our neighbors would have to have equipment stronger than entire galaxies for that. But the bottom line is, while all these signals are fascinating, there's still a ton to learn about them. All the planets of the solar system are slowly lining up. Mercury, Venus, Earth, Mars, Jupiter, Saturn, and Neptune are about to form a straight line. This event, called the Parade of Planets, occurs once every 176 years. The last time this happened was almost 40 years ago, and it was a great chance to explore all these planets in one go. On August 20, 1977, thousands of people gathered outside NASA's Kennedy Space Center.